Hey everyone, welcome to the review for midterm one, question one from the 2021 exam. Hopefully this will be good preparation for tomorrow's midterm. So good luck. I know you all got this. So let's just get started with this question. First step is always to read through the question and determine what the question is asking for. So we have a density apparatus and it wants us to compare the density of 5 fluids shown in the figure and then compare the pressure at the height of location I or 1 and also location 2. And it wants us to sort them from smallest to largest. And in the scenario that the order cannot be determined, please state equal or not equal. Great. So the question also gives us a hint that potentially we might not be able to determine some densities or pressures. So let's actually figure out what those are from just what we can see. So I know this is a really thin line, but right away we can see in tube C that there is a solid boundary right here. Great, so a solid boundary what does that mean? It means that we can't determine row 3. Why is that? Well, because of this solid boundary, right? We actually don't know the potential height that this could be. So actually, F3 could be higher, it could be lower. We're not sure because it doesn't relate to PATM, right? Because of this boundary. So throughout this question, we can't determine row 3. That makes life a lot easier. So we're looking for these things too. And another thing that we can see right away is that there's a solid boundary right here too, in tubes E and F. That means in this question, we also have a solid boundary. That means we cannot relate PE and PF can't be related to PA all the way to PD, right? We cannot because of the solid boundary. If fluid 5 was here, maybe we could compare, but that is not the case. So that also makes things easier. We can, however, compare PE and PF to each other by some relation, right? So please keep that in mind. You still can relate those two. So we still need to determine that. Great. So let's get started with our height number 1 right over here. So this is height number 1. As you can see, we know that because fluid 1, it looks like it covers just fluid 1, which is really nice because we know that if a fluid is continuous, and so same fluid is continuous at the same height, we know that those pressures are equal, not for another fluid. So fluid, what is this? Fluid 4, let's say, was over here, all the way down here. It's not equal because the fluid is discontinuous at this boundary right over here. Great. So let's keep going. So we know pressure A is equal to pressure B is equal to pressure C, and that's also equal to pressure D. That's really great. Awesome. So now all we have to do is find the relation between pressure E and pressure F. So let's take a look at this specific, these two tubes right over here. So I'm just going to take some time to draw this out right over here. I want to keep scrolling back and forth. So it looks like we have fluid 5 that's higher than fluid 2, right? So if we can think about this in another way, we have, before fluid 2 is added, we have fluid 5. Right? Fluid 5, right over here, F5. Then what happens is when fluid 2 is added, we add fluid 2, it actually pushes down oh my gosh, it pushes down on fluid 5. So fluid 5's height increases. So let's just draw that out here. Great, so we have fluid 5 right here, and we have fluid 2. That's right over here. Great, so to actually determine, we know that first fluid 2 is creating this increase in height, right, of fluid 5. We know then that fluid 2, the density of fluid 2 is greater than fluid 5. Another way to look at it is if we actually know, we know here at these points is PATM. If we start at this location where the pressures are equal and we travel this height right here, we get to PATM, right? You know, it's rho GH, right? But if we have to travel more to get to PATM, that means, so if the height increases, right, to actually measure that change, that means rho is lower. Basically, if we think of rho as, let's say, the speed that a person is running, right? If they're going at a slower pace, they're going to have to take longer time to get to their destination, right? So the more that you actually go at a slower pace, so the lower the rho, the more time it will take. So if we actually look here, if we have a lower density, that means we will have to travel a higher height to get to our PATM. So therefore, we know by just taking a quick look at this, that rho 2 is greater than rho 5. So let's keep going. That now, let's actually see how we can relate this to our pressures. So let me just erase this really quickly. Great. So what I'm gonna do is let's start at this point right here. Point here is star, point star, okay? And we are trying to determine so I'm just gonna just draw this out again so it looks better. If we take a look at the original diagram again, we can see that height is kind of in here and in here, right? So it's in the fluid too. So we can kind of mark it as, let's just say right here, arbitrary points, right? So if we're starting at pressure star, we know that it's equal first because it's a continuous fluid, right? Then let's actually travel up. Then pressure, this is pressure at point E, pressure at point F. So let's write it out. We know it starts at point star, and because we're going up, right, that means pressure should decrease, hence the minus sign. We know we multiply by GH, the same GH. Then we have for tube E, we have fluid 2, so rho 2. And for tube F, we have rho 5. So with this, we said rho 2 is greater than rho 5, right? So if we know that rho 2 is greater, right, this term is going to be bigger, right? That means the pressure at point E is going to be smaller, right? So therefore, we know pressure E is actually less than pressure F at this point, right? At this specific point, point number one. So let's finish this off right here. We know pressure E is less than pressure F. Great, would you look at that? We already have our answer for part 1. Great. So I hope everyone is following along so far. Let's actually move to part 2. So another thing to keep in mind is we know already that row 2 is greater than row 5. This will come in handy. So let's keep this in mind. Great. Now let's take a look at height number 2. So far, I'll just rewrite it right here. We know row 2 is greater than row 5. We also know because of this solid boundary right here, we can't relate row 3 to anything, right? So let's keep going. So on height 2, we have, wow, all different fluids, right? So let's start with one at a time. So let's look at A, and then let's see how we can relate it to B, right? Well, it looks really similar to this right over here, right? So let's actually use that same logic. So let's start with a point right here. We'll call this point star, right? And we're trying to write out PA and PB. We know it starts at point star. Then we know that we are going up, so we're going to be losing pressure as we go up. Now we have row 1, and we have row 2, GH. Remember that we just talked about rho. We know this point right here is PATM, right? So if it takes more through this fluid, more height to get to PATM, right? You know, rho GH. If we have more height and we have the same pressure difference, right? From this point all the way to here, this point all the way to here, it's the same change in pressure, right? All that matters now is because height is higher, we know that rho is smaller. So we know with this that row 1 is greater than row 2, right? That same logic. So now, if we know row 1 is greater, right, then we know pressure A is smaller. So therefore, we know pressure A is less than pressure B. Great. So I hope that makes sense. Now we know row 1 is less than row 2. What else do we know? We know row 2 is less, oh my gosh. We know row 1 is greater than row 2, and we know row 2 is greater than row 5. So let's just write out the row 5 right here too. Remember, the question asks us to also compare not only the pressures, but also the densities. So we're kind of working on this at the same time. So far, we know that so far, right? Looks like we're only missing row 4. So let's keep going. Now, let's do pressure C. And as we mentioned earlier, because of this solid boundary, we can't determine rho. If we can't determine rho, we can't determine the pressure at point C. So simply, we can't equate it to anything. So how nice is that? So we know this, and we know this. Great, how about we can do D in a little bit, but let's talk about E and F, right? Because we know we cannot relate E to anything or F to any of the other ones, but we can relate them to each other. One thing I can note right away right here, that's PATM, right? For 2E. So PE is equal to PATM, PE. So we know at PATM, that's the lowest pressure because as you go down, you increase in pressure, right? That looks really confusing, but yeah. So we know, therefore, PE is going to be less, and it's also asking us to go from smallest to largest. So let's start writing it out on the right. format. So we know PE is going to be the least. So we know it's less than PA. We know that PA is less than PB, and we know that we cannot relate PC. Great. So what about PF? Right? Well, we know first we can't relate PF to PA, PB, PC, PD, right? So we cannot relate to PA, PD, right? But we can relate it to PE, right? And we know right away, because it still needs to go up more, right? We know this pressure is greater. It's not at PATM. If this is PATM, we know this is something, the height, right? Rho GH added to PATM, right? So we know that PF is going to be greater than PE. So we do know PF is greater than PE, right? So let me actually write that out in the right format. So we also know this so far. Right? So all we need left is PD now. So let's keep going. Great. So let's talk about PD. It's related to PA. So if we take a look up here, sorry, I'm scrolling up and down so much, we can see right away it's similar to P and what we just did with PB, right? We have right here PATM. We can choose, I'm going to erase these two right here. We can choose star again, right? Or actually, let's choose star right where we know this fluid starts, and right around here. We know that those are equal, and we know that it takes a longer height h to get to PATM, right? So we know rho 1 is greater than rho 4. Same logic that we've continuously been doing. So because we know rho 1 is greater than rho 4, right? If we write out those again, PA, PD, P star minus, since we're going up, GH, same GH, and we have rho 1, and we have rho 4, and rho 4 is less than rho 1. That means this term is higher, right? Then this term is lower, right? So we know PD is greater than PA. So that's good, but we have PA in the middle. So do we know if it's greater than PB or just in between PA and PB? So that's now what we have to determine. So let's actually, instead of continuously scrolling up and down, I'm going to redraw this right over here. So let's compare rho 2 and rho 4. We also need to compare PB and PD. So I'm going to actually condense this, and we have right here, we have great. So we have right over here, we have fluid 2. And right over here, we have fluid 4, right? And let's just take a quick look right over here. There we go. I just drew B and D right over here. We can see that's the same right over here. The same height right here. So what I did was I just moved this over here so we can see. Let's write out the things that we do know. We know that up here right at these points is PATM. We also know right here, we know that it's the same pressure, right? So let's say P star. Great. So now let's move up to this position right here. We're going to denote that as smiley face. Smiley face. Great. So let's take a careful look right over here, and right here. This is fluid 1, right? So we know so far. What do we know so far? We know that row 1 is greater than row 4. We know that, right? And that was determined earlier. We are trying to now compare row 2 and row 4, and also pressure at B and D. So let's actually take a look. If we look right here, we're going to first travel up to smiley face, right? So we know at smiley face, at height smiley face, we have, remember this is B, this is D, we have pressure B is what? We have P star, we know P star is the same, right? Now we have minus, since we're going up, and we have the same height. I'm going to say this is height 1, okay? Height 1. Height 1, we have row 1, right? We have fluid 1, and this right here, this is fluid 1, and we have row 4, right? So we know because row 1 is greater than row 4, right? This term is higher, meaning more is subtracted. That means PB is lower. So therefore, at smiley face, right? At the smiley face, we know that pressure B is less than pressure D, right? But we're not there yet. We need to compare first the rows. The row will give us the actual answer. Let's keep going. So now let's actually get to PATM. Let's get to PATM, right? Let's call this height 2. Height 2. So we know already at smiley face, this pressure is less than this pressure. This is higher pressure, right? But let's keep going. PATM, we're going to keep going up, right? So we're starting at PB as smiley face, right? It's that smiley face. Minus, since we're going up, what do we have now? We have row 2 GH, and we have row 4 GH2, right? We just determined that, hey, PB is less than PD, right? We determined this. So that means if PD is greater, right? That only means that row 4 must be greater as well to get PATM, right? This is fixed, right? We know that to equate for this difference caused by this, right? That means to travel the same exact height, row 2, right, is actually going to be less than row 4, right? To equate for the difference. We just determined that. So if that was confusing, just rewind and watch again. It's kind of really important to know how this was determined. So we compare at first the height of the smiley face, the pressures, and then since the height to the ATM, PATM is the same, right? We had to account for that difference in the row, right? So we know that row 4 is greater than row 2. Now let's finally bring this all together, right? So we know right here, we wrote right above, row 1 is greater than row 4. Great, just like that. And we also know from here, row 5 is less than row 2. Row 5. So we have all of these right here. And lastly, we know that row 3 cannot be equated. So let's just double check. Therefore, you have already your answer for another part of this question. Right there. Right? Now, lastly, let's actually look at what let's compare PD. Right? So what I'm going to do is I'm going to draw it out one more time. And please note that I'm just walking through this slower. Great. Here, and then we have here, and then here, right? So let's actually take a look at the question one more time. It looks like at height 2, it looks like we're in the middle of fluid 2 and fluid 4, right? So let's actually draw that out too. Great, so it looks like the point in question is around here and around here, right? It's actually asking us PV and PD. So let's start here. We moved up from star all the way to smiley face, right? And we determined at smiley face, right? Let's scroll up just a little bit. We determined smiley face, PB is less than PD, right? Okay, but what about going up all the way to the point in question? What is the pressure at this height? Well, let's think about it. So we know row 2, right? We know row 2 is less than row 4, but we're traveling height, but we actually don't know what these actual values are. They could be really close, they could be really far, right? Although we know this equality, we actually don't know the specific height and what these values are. So actually, PD cannot be related to PB. I don't want to write that it's not equal to. Can't be related. I hope that makes sense why it can't be related. It can't be related because although we know this at smiley face, right? We don't know these actual values, right? And even if we do know the rows, we don't know if PB will be greater than or less than PD at that point, or even equal to. We actually don't know. So therefore, since we know we can't relate it, let's go back to what we just determined earlier. We have, I'm going to just copy and paste this. So I just pasted this right from above. We know PE, PA, PC, and we also know we can't relate PD, right? And we know PE is less than PF. Great. But we also do know that PA is, we put it right here, but PA is less than PD. So we do still want to include that in here. So what I'm gonna do, see if I can move just this part up. Okay, that really ruined it. But we know PA is less than PD. Great. So we do know these, and this is your final answer for this is at height 2, right? Height 2, we have our rows, and at the very top of the page, we have our position 1. So that's just an explanation of question 1 on the midterm 1. Please email me if you have any other questions. I'm more than happy to help. But I really do wish you all the best of luck. Please take care of yourself. Make sure you're taking breaks. Stay hydrated. Get enough sleep. Just know that this is just the first midterm in this course. And it is a really challenging course. So don't be too hard on yourself. You're going to really do great. And just be proud of how far you've gotten to this moment and embrace the challenge. Hope you have a great night and see you soon. Bye.